This is a quick video reviewing using binomial probability and with one example question, which is, what is the probability of getting 6 correct answers on a 10-question multiple choice test with 4 answers per question? An example would be the typical question where you've got to pick from A, B, C, or D. And this is going to assume completely random guessing. Okay, you don't know anything. You ever feel like that? Well, then you need to know how to calculate your probability of getting the question correct. All right? The general formula for binomial probability is listed right over here in yellow. And let me tell you what all those numbers and variables mean. First of all, this part right here it really is a combination of n items taken x at a time. In our case, it's how many total questions are going to be on the test, which is 10. Okay, that's how many I have to pick from. And I want 6 to happen. All right? The 6 represents the event that you want to happen. Binomial probability means there's either the event can happen or it won't happen. All right, and that's the BI in binomial means 2 things. Okay? Therefore, we've got to keep on multiplying here. The P stands for the probability that the event will happen. Well, in the case of a multiple choice test with 4 answers that I'm guessing, the odds that I'll pick the right answer is 1 out of 4. And I like to use the decimal version of that, which is 0.25. Okay, and that's the probability that I will guess correctly. The exponent that goes right above it is how many times I want that to happen. Well, in this case, it's 6. The Q is the probability the event won't happen, which is, in the case of a multiple choice test, what's the likelihood that I won't guess correctly? That's going to be 0.75, which is the same as 3 out of 4. These 2 probabilities, that it won't happen, that's the 0.75, and that it will happen, they have to add up to 1. That kind of makes sense. And the exponent for this one is how many times that event won't happen. Well, in this case, it's 4. Okay? These 2 numbers, the exponents, need to add up to the total, basically the total number of trials. In our case, we've got 10. Now, you can use your graphing calculator and figure this all out. And you're going to get 210 times, I'll just put parentheses around here. Let's see if I've got that number handy. 0.000244 times 0.31. Now, if you put this all in this whole thing in the graphing calculator as one expression, you should get 0.01622. Now, here's the trick. You gotta be really careful about this and recognize that this answer right here is probability in decimal form. If I want it in percentage form, I need to move that decimal over, okay? And what I'd be talking about in a percent is roughly 1.6%. Pretty slim odds that I could guess 6 questions correctly out of 10. I also want to talk really quickly, since I have probably a little bit of the 5 minutes left, about how you can manually calculate a combination if you didn't have a graphing calculator, because that's actually pretty easy. I'm going to do that over here. 10 combination 6 means on the numerator, I'm going to do 10 factorial, but I'm going to stop after 6 numbers. 10, 9, 8, 7, 6, and 5. Okay, that is 6 numbers, so that's how many I'm picking. Okay, and the denominator is going to be 6 factorial. How many I want to pick? Okay, 6, 5, 4, 3, 2, 1. Then you do a bunch of canceling out. And I've got to cross out the 5 and the 2 6s. I'll also cross out the 4 and the 2 to go with the 8. And then I'll probably simplify the 3 and the 9. Then I have 10 times 3 times 7. And I would do it this way. 3 times 7 is 21. 21 times 10 is 210. So I would get the same answer as my calculator over here. Okay? There you go. There is how to do binomial probability.